చూడండి. So this is the next concept, capacitance of spherical capacitor. See, here you are seeing one spherical capacitor, cylindrical capacitor. Capacitance of a cylindrical capacitor. Okay. See, here you will find two cylinders. No? This is one inner cylinder and this one is an outer cylinder. So listen carefully. To the inner cylinder, we are giving some positive charge. Inner cylinder ki manam positive charge ni ista unnam. Clear nama? So this inner cylinder will induce negative charge on the inner surface of outer cylinder. No? Are you able to understand what is happening? So this positive charge, it will induce negative charges where? On the inner surface of outer cylinder. Similarly, if there is no grounding here, then what happens? Positive charge will develop on the other side, no ma? Can you say why positive charge will develop? Chapandi. We have given charge to which cylinder? We have given charge to inner cylinder. But outer cylinder was neutral, no? Outer cylinder it was neutral. So therefore what happens? If this positive charge induces negative charge on one side, automatically positive charge will be induced on the other side. This is what happens, no? Because the total number of negative charge and positive charge on the outer cylinder will be 0. It should be neutral, no? Actually, are you able to understand, ma? But if I ground this one, then what will happen? Grounding చేస్తే ఏం జరుగుతుంది ఇంతకుముందు చదువుకున్నాం కదా. If I ground this one, then what happens is all this positive charge it will flow to the ground. Clear, no? And there is no net positive charge present on the cylinder. Are you able to understand what is happening? And the capacitance of this capacitor is given by this relation. C is equals to 2 pi epsilon naught L. L means what? Length of the cylinder divided by natural logarithm of B by A. What is meant by B here? B is called as the bigger radius. That is the radius of the bigger cylinder. And A is the radius of the smaller cylinder. So this is the equation. Are you able to understand? Right now. Okay. So see this next concept. My energy is stored in a charged capacitor. See, ma'am. So consider this is a capacitor and we are connecting this one to a battery. Okay, ma'am. Positive charge and negative charge. So capacity of this battery is V, ma'am. Then some amount of charge will be stored in between the plates of this capacitor. No? Already we discussed, no? What battery will do? Battery will remove electrons from the positive plate and it will deposit on the second plate. This is what happens, no? Here what is the charge present? Positive charge. Positive charge means this side of the battery is at higher potential, no? So this higher potential end will attract the electrons on the first plate. Okay, so electrons are continuously traveling in this direction and in the process they go and deposit on the second plate of the capacitor. All these electrons will get deposited. If all the electrons get deposited and here electrons are removed, no? So here what is the charge we will get? We will get a positive charge on the first plate, negative charge on the second plate. This is the method of charging, no? Okay, ma? And the amount of energy which is stored in between these plates of the capacitor, the equation is this much. One equation is half CV square, half QV, and one more equation is Q square into 2C. Okay, ma? And here one more point which we should write is, in between the plates of capacitor, okay, ma? Energy is stored in the form of what? Energy is stored in the form of electric field. Okay, ma? So in between the plates of the capacitor, energy is stored in which form? Energy is stored in the form of electric field. Are you able to understand? What is the reason? Already we have studied, no? For example, if this is positive plate, okay, and this is negative plate. So electric field will be always directed from positive to negative, no? This is the direction of electric field. Clear, no? So energy is always stored in which form? Energy is stored in the form of electric field in between the plates of a capacitor. And the equations are, these are the equations. Half CV square, half QV, Q square by 2C. Is it clear? Next, if I discuss about work done by battery. Okay, ma? Work done by battery. battery is doing how much work? Can you say, anybody? What is these equations? These are the equations of energy stored between the plates of a capacitor. But in storing this much energy, battery will do how much work? Chapandi? No. See, already we studied, no? V is equals to W by Q. Do you remember this equation? What is meant by potential? Potential is nothing but work done per unit charge. This is called potential, no? The amount of work which we are doing to take electron from infinity and to place at certain point, that is called as potential. So potential is nothing but work done per unit charge. So therefore, work done by battery is how much? Work done by battery is equals to V into Q, no? Huh? But if you see here, how much amount of energy is stored in the capacitor? Work done by battery is Q into V. But energy is stored? Only half of that, no? Arthamautunda? Battery will do how much work? Q into V work. But capacitor is storing how much energy? Only half of that energy. It means out of the total work done by battery, capacitor will store only half. What happened to remaining half of the energy? Heat energy. Okay, ma? See, in transferring the charges ikkada nunchi ikkada varaku nenu transfer cheyali kada. In that transferring process, half of the energy will be wasted. Battery correction chesthe circuit vedekutunda vedakkada. Circuit gets heated up, no? Why it is heating up? Because it has to travel electrons, no, ma? And any wire, even though if it is a very good conductor, any wire will have some resistance. Any wire will have some resistance. To overcome that resistance, definitely battery loses its half of its energy. And only remaining half only it will be stored in the form of electric field or energy in between the plates of a capacitor. Are you able to understand? So write down. So therefore what I write here, so battery does QV work. Okay, ma? But out of it only half of energy is stored. Okay, ma? Half of the energy is stored in between plates of capacitor. In between plates of capacitor. Okay? Then what is happening to remaining half? Remaining half is wasted as heat energy. Are you able to understand me? So how much amount of heat energy is wasted? Half of it. So therefore, energy wasted as heat. Energy wasted as heat. How can I calculate? Energy supplied by battery. Energy supplied by battery minus energy stored. Energy stored in between the plates of capacitor. Okay, ma? Energy stored in between the plates of capacitor. Okay. So energy supplied by battery is how much? QV. And energy stored is how much, ma? Half QV. So therefore energy wasted as heat energy is half Q. That's it. So are you able to understand? వీటిపైన కూడా మీకు ఇంతకుముందు బిట్స్ అడిగి ఉన్నాడు. సో యూ షుడ్ అండర్స్టాండ్ ఇట్ కేర్ఫుల్. ఓకే, దట్స్ ఇట్. సీమా. సో ఫర్ ఎగ్జాంపుల్ ఇఫ్ కెపాసిటర్స్ ఆర్ కనెక్టెడ్ ఇన్ సిరీస్ అండ్ ప్యారలల్ కనెక్షన్, then which of these equations can I use to represent the energy stored in between the capacitors? Okay, so these are the equations of energy, no? Half CV square, Q square by 2C, half QV. These are the equations of energy. So consider if three capacitors are connected in series. Three capacitors are connected in series, no? So series connection means immediately what you should remember. Series antane meeku em gurtu ravali cheppandi. Current, you are discussing about current. Current will not be divided in series connection. Charge? Induced charge means series connection means immediately what you have to understand is that on every capacitor we find the same charge. అదే కదా ఇంతకుముందు మనం డిస్కస్ చేసింది. ఓకేమా? On every capacitor charge stored will be same amount of charge will be stored. For example, on this capacitor plus Q, on the next capacitor minus Q, again plus Q, again minus Q. So like the same amount of charge will be induced, no? Because already we discussed that battery will supply charge only to first plate of first capacitor. Remaining all the charges, they are induced charges. Are you able to understand? So therefore, to represent energy, out of them which equation is better? I better use this equation, no? Clear, no? Why? Because the charge stored on every capacitor is same. Capacitances may be different. And potential difference also may be different. Okay, so I can use this relation. For example, I can write, so total energy stored is equals to, I can write Q square by 2C1 plus Q square by 2C2 plus Q square divided by 2C3. I can write like this, no? Okay, ma? Okay. And see if I can use this relation, ma? Half Q V1, okay, ma? Half Q V1 plus half Q V2 plus half Q V3. I can write this one also, no? Why I can write this relation? Because the charge stored on every capacitor is same. Potentials may be different. Is it clear? Now can you say which equations I can use on parallel grouping, ma? What is meant by parallel first of all? Parallel means charge, charge divides. What is the common thing? Potential is common, no? On the first capacitor, second capacitor, third capacitor, on every capacitor, the amount of potential stored is same. Already we discussed, no? In series connection, charge will be distributed equally, same charge. And in the case of parallel connection, potential difference on every capacitor will be same. Okay, so therefore which equation I can use? I can use this relation, no? Okay, ma? So work done is equals to half C1 V square plus half C2 V square plus half C3 V square. I can write like this. Are you able to understand? Similarly, see if there is any other equation. Potential is same, no? Half QV, potential difference on every capacitor is same. So one more method in which I can write is half Q1 V square plus half Q2 V square plus half Q3 V square. I can write like this also, no? Because of the total charge which is generated. So out of the total charge Q, it divides into three branches, no? Here Q1 amount of charge, here it is Q2 amount of charge, and here it is Q3 amount of charge. Charge can be distributed like this. Are you able to understand? So by taking some symmetry, we are trying to write these equations. అర్థమవుతుందా ఎందుకు రాస్తున్నామో ఇలా? Right. Okay. So this is half QV, not QV square. Okay. Okay. Sima. So next we are discussing about energy density between plates of the capacitor. Okay, ma? So what is meant by energy density? Energy density is nothing but energy stored per unit volume. Okay, ma? So in between the plates of capacitor, some volume will be there, no? So two capacitors, there is some area, there is some distance also. Definitely there will be some volume, no? So total energy stored per unit volume is how much? That I want to calculate. Are you able to understand? How can I calculate? Energy stored, one relation I can use half CV square, no? Divided by unit volume is nothing but area of cross section into distance. Can I write like this? What is the area of each plate? Area of each plate is A. Area multiplied by distance, volume only, no? So half CV square divided by A into D. So next, what is the equation to calculate capacitance of a capacitor, ma? Equation to calculate capacitance of a capacitor. Epsilon naught A divided by D. This is the equation, no? Epsilon naught A divided by D. So multiplied by V square divided by A into D. So I got relation up to here. Okay. So I will do one thing. I will cancel area and area, ma. So therefore energy density you can write it as mu also. So this is equals to half epsilon v square divided by d into d is d square. I can write like this also. Is it clear? Similarly, we know E is equals to V by D. This relation already we know, no? Electric field is nothing but potential difference divided by distance. So therefore, instead of V, what I can write? Instead of V, I can write E into D. Clear, no? So take this value and substitute here. Okay, ma? If I substitute here, energy density, how I can write half epsilon naught multiplied by V can be written as E into D whole square divided by D square. So D square and D square get cancelled. So therefore, mu value is how much? It is half epsilon naught into E square. Okay, ma? So this is the equation to calculate energy density between the plates of a capacitor. Are you able to understand? అర్థమైంది కదా ఎలా డిరైవ్ చేసాము? Derivation is just for your understanding. Okay, this is the equation which you are supposed to remember. Energy density between the plates of capacitor is half epsilon naught into E square. Okay, బ్యాటరీ దొరికినంత వరకు